Hi class, this is another question from chapter 6. This one is about MBA's deferred compensation plan, and it has three parts to it. So here is the sample question. Again, you're going to have different numbers, right? Okay. Let's go one by one. So step 1. The first question is asking how much has accumulated in Rodman's deferred compensation account. Well, this guy is saving. It says assume Rodman right here has had 6,400 deposited at the end of each year for 30 years. So we are talking about saving 6,400 every year at the end of each year for 30 years. So we right away again notice that this is an annuity question. There's a consistent amount, same amount being deposited to a bank for 30 years. Also, the percentage here in this question is 8%. For me, it's 8%. So what you want to do is you want to go to annuity table. So which annuity table? Well, since I don't know how much it's going to become in the future, it's asking how much has accumulated in Rodman's deferred compensation account. In 30 years, I don't know how much it's going to become. I'm depositing $6,400 every year at the end of year for 30 years. But in the future, in 30 years, how much is it going to become? That's the amount that I don't know in the future. So therefore, I'm going to go to future value annuity table. Since this amount is being deposited at the end of each year, I'm going to use annuity table, just regular annuity table, not annuity due table. Again, annuity table is being used when the cash flows goes in and out at the end of a period. If cash flows occurs in the beginning of a period, then you will use annuity due table. So if we go to annuity future value annuity table, and for me, I look up under 8%, and the number row will be 30 because we are talking about 30 years. So if I do that, I will get this particular rate. The way we use the table again is annuity amount times the rate I find from the table should give me the value. So in this case, it's a future value. If I put this amount every time for 30 years, at 8%, I will accumulate this much. Now let's look at the second question. Second question is asking, how much will this person be able to withdraw at the beginning of each year if we elect to receive payment for 16 years. Now we are dealing with annuity again because it says this person wants to withdraw certain amount every year for 16 years. But one thing we have to notice is that it says he wants to withdraw the fund at the beginning of each year. So when a cash flow goes in and out consistently in the beginning of each year or each period, we use annuity due table. And which annuity due table should I use? Present value or future value? Well, in this case, we're going to be using present value annuity due table because we are going into the future in 30 years. This guy has been saving $6,400 every year for 30 years. Now it's 30 years later. He is ready to retire. At that point, how much does he have? he has accumulated $725,000 in his pension fund. So at that point, although right now we are thinking into 30 years, but imagine you are that person. You've been accumulating $6,400 every year, and finally, after 30 years, you are done with the work, you're going to retire. At that point of time, you have $725,000 in your bank. So then you must be wondering, why should I use present value annuity table? Why am I not using future value table for this second calculation? Well, the reason is, let's take a look at how we use that table. So I made a little calculation here. See, the way we use present value table is like this. If you know the annuity amount, right, here, you multiply annuity amount times that rate you're going to find from this annuity table. If you multiply the two, then you're going to get present value. So then you're trying to use this formula or this table. If you know any of these two of the three elements, then you could use this formula, find the third element. So take a look what we know of this. Out of these three elements, what do we know right now before we do any calculation? We know present value because in 30 years, that $725,000 we calculated on step 1, that will be that person's present value at that point of time. Now, what we are trying to find on number 2, item B, is the annuity amount, meaning how much can you withdraw? We don't know. That's the X that we are trying to find. So annuity still we don't know. What we know is though, this guy wants to withdraw that fund for 16 years at 8%. So 8% did not change. Nobody said the percentage will change. So assuming the 8% investment percentage is not changing, and if we keep it at 16 years, then we could go to that table and find that particular rate, right? So if I go to that present value annuity due table and go to 16 years, row 16 and 8%, I find this particular rate. So if I multiply that rate times whatever the annuity amount that this person wants to withdraw, if I multiply the two, I should get the present value, right? Based on this formula. So then that's why this is the table we should be using, because this table, the way we use it, has these three elements that we could use to find the unknown value. From these three elements, we know already two of them. So this is the right table that we should be using. So then let's just plug in the number. So for present value, I put 725, and for the rate, I go find it using this 16 years and 8%, and I found it. And you plug it in. So once you plug it in, I'm just gonna try to find the X. So I need to find annuity. So we are doing simple algebra now. So how do you do that? When you have this multiplication on top, on one side, what you do is you divide both sides with the same number, right? So if you divide this side, annuity times the rate, divided by this rate, and also I do the same thing on the other side, of equation, then I could rewrite it like this. So if I redo the calculation I'm writing, it says annuity should equal to the present value divided by the rate I found. So if I do the calculation, I get annuity equals to 75,842. So on our publisher's answer, this is the way they showed it to us. They just gave it to you right away. The present value divided by the rate should equal to this. So I thought some of you might be wondering, why are we using present value annuity due table? It could be confusing. Why? Because the way we use the table is like this. You multiply the rate by annuity, then you're going to get present value. So present value at that point of time in 30 years, that amount that we calculated on step 1, what is the present value at that time? You have that money in your bank now at that point, and you want to take out annuity every year for 16 years at 8% investment. So what do? You plug in the elements you know, and you do the calculation. Just find the X, which is annuity in this case. Now the third one is a little more complex then. Well, it's talking about same situation, except that this time they gave you annuity. And instead, you don't know how many years now. So what you do is you set up the same formula. So here, this is the old formula. If I go to my new formula down here, I made it. So this is the same formula, right? Annuity times the rate I'm going to find from this table should equal to present value. So I know present value. I just plug in that number. But this time I know annuity, so I plug in annuity. But I don't know the rate. Why? Because I don't know how many years I have to, he will be able to withdraw if I continue to withdraw 69,000. So then this element became X. This is the X I need to find out. So what I do is to isolate this X, I divide both sides by 69,000, right? Then these cancel out. And if you rewrite the formula here, present value annuity due rate I will be finding should equal to present value divided by 69,000. So if I continue to do that, present value annuity due rate I should be finding from this table should equal to something like 10.5074. So I need to go find what represents this rate. So I'm going to go to table and try to look for under 8% because I know it's going to be under 8% because investment environment did not change. They did not say it's going to be 10% or 12%. It is still 8%, but I just don't know which year. So here is that annuity due table, present value annuity due table. So I'm trying to find where is that rate I calculated belongs to on this table. So I go 8%, right? And then look for that 10 point, what was that amount? 10.5074. So I'm going to try to find that 10.5074 on this table under 8%. So where is it? It's somewhere here. And you could see it's either 19 or 20. And what I do is I find that rate that is close to the rate I calculated. If I do that, this is the correct answer is 19. So that's how you do the third question. So the way the publisher will show you the answer, I don't know if you see same thing I see. This is what they do. They give you the calculation right away. So if you wonder why are we calculating like that, that's because for this reason. We set up the formula first. You plug in the information that you already know, and you find the X. When you find that X, in this case, which is present value annuity due rate that you will be finding from the table. So once you find the table, you go to the table and literally, physically searching that rate that's gonna applicable to you. So whichever is more closer to your rate you calculated, that will be the answer in this case. Here down here, they give you information here. So the guy will be able to receive 69,000 per year for 19 years. with a partial payment in year 20 of approximately they calculated the remaining amount. So because the rate was in between 19th and 20th year.